We have next example. Before you are going to start solving any problem, it's always good to check one more time what is the most significant variable and least significant variable. I mean, which variable represents the most significant bit and which variable represents the least significant bit, because you're supposed to prepare the K-map for the particular problem. In this case, C represents the most significant bit. That's why I'm going to write C over here and BA at the top of the map. So that's why I'm going to have C note C, and I'm going to have BA, 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 and we're supposed to write the negation bar over every single variable, which is over 0 or low. Next, we're supposed to convert this sum of the products to the standard sum of the product. It means that we're supposed to have 3 variables in each single term. What variables someone is going to ask? Let's take a look at this expression. We have C, B, A. The domain for this expression is C, B, A. We have 3 variables. That's why every single term is supposed to have 3 variables in order to have standard SOP. The first term is missing B. That's why I'm going to multiply C naught, A naught by B or B naught. Or next one I have B naught, A naught. This one is missing C. That's why I'm going to multiply this one by C or C naught. Or C naught B. This one is missing A. A or A naught. This one is missing A again. So I have C, B, and I have A or A naught. Next, I'm supposed to perform the distribution. I have to distribute these terms into the parentheses. That's why I'm going to have over here C naught B A naught. Remember, you're supposed to keep the order C B A. That's why when you're going to multiply C naught A naught B, you have to write C B A. C naught B naught A naught. C naught B naught A naught. I'm finished with this part of the problem. Or this one, I'm going to have C B naught A naught, and I'm going to have C naught B naught A naught, or C naught B A, or C naught B A naught, or C B A, or C B A naught. C naught represents 0, so this is 0, 1, 0. This is binary 2. That's why I'm going to write 1 in cell number 2. This is 0, 0, 0. This is binary 0. This is 1, 0, 0. This is binary 4. I have 0, 0, 0. This is binary 0. It's marked already. I have 0, 1, 1. This is binary 3. I have 0, 1, 0. This is binary 2. It's marked already. I have 1, 1, 1. This is binary 7. And I have 1, 1, 0. This is binary 6. Next, I'm supposed to group these ones. My first group is going to contain these 4 ones, and another group is going to contain these 4 ones. Let's talk about this group first. This group is placed in 2 rows. At the side of these 2 rows we have complements, that's why we are going to ignore them. And at the top of these 2 columns I have A naught. That's why I'm going to write over here A naught. Or these 4 highs, or ones you can call, are placed in 2 rows and 2 columns. At the side of these 2 rows we have complements, that's why we ignore them, and at the top of these 2 columns we have B. So I'm going to write B over here. If you want to implement this expression, this is OR gate with 2 inputs where A is connected to the inverter and input B. These are the solutions to my problem. And we have next example. Again, just take a look at the domain of this expression. We have A, B, C. We have 3 variable expression. Okay, so in order to convert this to standard SOP, you're supposed to make sure that every single term is going to contain 3 variables. The first term is missing C. That's why I have to multiply the first term by C or C naught. And I have B naught, A naught, or the second one is missing B. That's why I'm going to multiply this term by B or B naught, C naught A. Or this one is missing B and C, but I'm going to do one step at a time. So I'm going to multiply A by B or B naught. Just take a look at the order. C represents the most significant bit, A represents the least significant bit, because C is at the left side and A is at the right side. That's why I'm going to keep this order. C, B naught, A naught, C naught, B naught, A naught, or C naught, B, A, C naught, B naught, A, or B, A, or B naught, A. If you want to do everything step by step, you're supposed to copy everything, whatever we don't use, I mean whatever is already set to 3 variables, and we have to add 3rd variable to these 2 terms. I'm going to copy everything, whatever I'm not going to use at this moment. So I have C, B naught, A naught plus C naught, B naught, A naught, or C naught, B A, or C naught, B naught, A, or, and I have BA and missing C, that's why I'm going to write C or C naught, and I have BA or C naught, and I have B naught A. Again, I want to do everything step by step. I have again C, B naught, A naught, or C naught, B naught, A naught, or C naught, BA, or C naught, B naught, A, or this time I'm going to have C, B, A. Next one I'm going to have C naught, B, A, or C, B naught A or C naught B naught A. 1 0 0 1 0 0, this is binary 4. I have 0 0 0, this is binary 0, mark 0. I have 0 1 1, this is binary 3, mark 3. We have 0 0 1, this is binary 1, marked 1. And I have 1 1 1, this is binary 7, you have to mark cell number 7. I have 0 1 1, this is cell number 3, 3 is already marked. And I have 1 0 1, this is 5. And I have 0 0 1, this is binary 1, 1 is already marked. This is my Karnaugh map, and next I have to group my highs. I have 4 of them over here, and I have another group of 4 over here. Let's take a look at the first group. The first group is placed in 2 rows and 2 columns. Because at the side of the 2 rows I have complements, I'm going to ignore them. And at the top I have B naught. This is the common variable for these 2 columns. The next group is placed in 2 rows. I ignore the complements and I have to look at the top. At the top I have A. This is the final expression, the simplified expression for this problem. And if you want to implement it, this is OR gate with 2 inputs. Input B goes with inverter because I have negation bar, and I have input A. And these are the solutions to my problem.